Have you ever stopped to think about what it takes to build a digital skyscraper? Not one made of steel, but one built entirely out of code. A skyscraper designed to serve millions and millions of people every single day. We're talking about a massive subscription content platform, and today we're going to get a look at the actual architectural blueprint. All right, let's get into it.
So this is the big question, right? This is the core challenge. We're not just talking about a website that looks pretty. We're talking about engineering a massive, lightning-fast, and super secure digital city that literally never sleeps. I mean, the numbers are just staggering, and the stakes couldn't be higher. So where do you even start?
Let's just let that number sink in for a second. 10 million people. That's more than the entire population of New York City, logging in, uploading content, subscribing, and interacting every single day. Every single architectural decision we're about to walk through is driven by the need to handle this crazy scale and to do it flawlessly.
Okay, so to really get how this digital city is put together, we're going to follow the master plan. First, we'll lay the foundation, figuring out what we need. Then we'll check out the overall blueprint. After that, we'll take a tour of the key districts where all the action happens, look at the utilities that keep everything running smoothly, and finally, we'll talk about the tough choices and what's coming next. Any great project, whether it's a building or an app, starts with a super clear plan. Before you can write a single line of code, you have to know exactly what the system needs to do, and just as important, how well it needs to do it.
So it breaks down into two camps. On one side, you've got the functional requirements. This is the stuff you, the user, actually see and interact with. Uploading media, subscribing, sending messages. You get it. But on the other side, you've got the non-functional requirements. These are the promises the system has to keep. It's got to be available 99.9% of the time. It needs to be super fast, totally secure, and ready to grow bigger without breaking. And you absolutely cannot have one without the other.
All right, with our foundation set, now we can zoom out and look at the high-level master plan. Think of this as the 30,000-foot view of our entire digital city, showing how all the different pieces are connected and how they talk to each other. Now, what's really cool here is how it's all layered out. Up at the top, you've got the clients. That's your phone, your web browser. Every single thing you do sends a request that goes through the API gateway. You can think of that like the main entrance in the security desk of a giant building. From there, your request gets routed to either a core service, which handles the really important stuff like payments, or a feature service for things like your feed. And holding it all up from the bottom is the heavy-duty infrastructure, the databases and storage that everything is built on. Okay, let's zoom in a little closer. We're going from that big city map down to a street-level tour of the most important districts. These are the core features where all the magic happens. First stop, the financial district. This is the engine that powers the entire platform. And a really key decision was made here. You do not try to build a payment system from scratch. No way. Instead, the system very wisely plugs into trusted giants like Stripe. This basically offloads all the insane complexity of security and compliance, which lets the platform focus on its main job, managing subscriptions and making sure creators get paid accurately and on time. All right, next up, let's follow a single video on its journey. When a creator hits upload, that file doesn't just go sit on some server. First, it's sent to this massive, super durable object storage. Then comes a critical step, transcoding. It's just a fancy word for creating a bunch of different copies of the video. A high-quality one for your laptop, a smaller one for your phone, one for a slow connection, another for a fast one. Finally, all those different versions get pushed out to a content delivery network, or CDN, which is basically a web of servers all over the world. This is what makes sure that when you press play, the video is already nearby, so it just loads instantly, no matter where you are. The fade. This is where users spend most of their time, right? So it has to be fast, it has to be relevant, and it has to be fresh. Now, you could try a push system, where every time a creator posts something, the platform sends it out to all their followers at once. But at this scale, that would be like sending 10 million text messages every single time someone posts a photo. The system will just collapse. So what's the smarter way to do it? The answer is what's called a pull-based system. So why does this pull idea work so well? Well, instead of the server pushing updates out to you constantly, your app simply pulls or asks for the latest posts from creators you follow right when you open it. It's just way more efficient because you're only requesting what you need right when you need it. And here's the brilliant part. Because the answer to that pull request can be heavily cached or stored temporarily, the feed feels completely instantaneous to you. It's a really elegant solution. So we've toured the main districts. Now let's go underground and look at the utilities. All the hidden infrastructure that makes our city not just work, but also be incredibly fast and safe for everyone who lives there. A huge mistake people make is thinking one kind of database can do everything. This architecture is much smarter. It uses the right tool for the right job. For all the superstructured, critical data like payments and user profiles, it uses a relational database. Think of it like a perfectly organized filing cabinet. But for the crazy high volumes of less structured stuff, like billions of direct messages, it uses a NoSQL database, which is more like a flexible, infinitely expandable scrapbook. Now, to get that feeling of pure speed, the system leans heavily on caching. Just think of it as the platform's short-term memory. Instead of going all the way back to the main database for everything, it keeps the most popular stuff ready to go in an instant. And you can see here, almost half of that precious memory is dedicated just to the feeds of popular creators. That's why the main page loads in the blink of an eye. And of course, none of this matters one bit if the platform isn't safe. Security here is all about layers. Data is encrypted when it's moving across the internet and when it's just sitting on a server. The media itself is protected with special links that expire to stop people from just sharing it everywhere. And behind the scenes, you have a combination of machine learning and actual humans working together to scan content and handle user reports to keep the community safe. Look, no design is ever perfect. Building a system at this kind of scale means you have to make some really difficult choices and face challenges that never go away. So let's look at the trade-offs that were made with this blueprint and what's waiting on the horizon. This architecture is incredibly powerful, but that power comes at a cost. Storing all this media and serving it around the world is enormously expensive. There's a constant, never-ending battle against payment fraud. The system has to be built to handle those sudden, massive traffic spikes when a creator goes viral without crashing. And maybe the biggest headache of all is the ongoing fight to prevent content leakage. It's a huge technical and security challenge. So, if you boil this entire thing down, what is it? At its absolute core, this system is a highly specialized machine. It's built for two things: to handle massive amounts of media and to process payments securely. Everything, every single piece of this architecture is there to support that central purpose of secure monetization and scalable delivery. And that, of course, brings us to the future, because the digital world never ever stands still. New features like AI-driven recommendations or real-time live streaming, these present entirely new kinds of technical challenges. This blueprint we've looked at is a masterclass in building for today's scale, but the ultimate test for any architect is always the same. How do you evolve your creation for the demands of tomorrow?